Welcome. In this video I'm going to show you how you can determine Cohen's G using Python and the stikpetP library. If you don't want to use my library, you can see another video where I explain it without. This video is mainly about how you can actually obtain Cohen's G, not so much if you should, and also not so much on how to exactly interpret it. Although it's very simple, the Cohen's G is simply the observed proportion minus 0.5. It's an effect size measure, sometimes used with a one sample binomial or a one sample proportion test. I'm using Jupyter Lab, and I'll leave a link to this Jupyter notebook in the description below. Currently I'm using version 3.97 of Python, but I think this also works with 3.10 and perhaps also higher ones. Cohen actually also gave some rules of thumb for interpretation. I'll get back to those later on. Of course, to show you how it works, I need an example. So I'm going to store that as a pandas data frame. So I'm going to be loading pandas and then use read CSV to actually load an example of student statistics. Now the field I'm going to be using must be binary, and this is a relatively old survey and there were only males and females. So that makes this, in this case, binary. And we might already see that there are quite a lot of males and not so many females. Now, in order to use the stikpetP library, you will actually need to install it. It's available not directly from via pip install, but you can use this link, which is from my GitHub account, and I'm gonna load it then in. I've already once installed it. I'll load it and I'll abbreviate it to PS, which are my initials. The function of interest is Cohen G. ES for effect size. It only has two parameters, data of course, and the code. So if you have more than two categories in your data, then you can specify the two codes that you actually want to use. I'm simply going to store the result as G because it's simply going to give me a value. So it's about 24%. So 24% above or below the expected 50%, which seems quite high. But not unexpected, as we saw from the counts already. Now, the library also has a function called th for rules of thumb for Cohen's G, so we can actually use that to get that interpretation, and apparently we could classify this as median using the Cohen's rules of thumb. Although with these rules of thumb you should always be careful because they can depend on the field that you're working in, and some will say you shouldn't be using them, but I didn't want to deprive you of them. Alright, if you don't want to use the library, then feel free to watch the other video where I go over the part where I'm not using my own library, and these were the references I've used. Alright, I hope this was helpful and thank you for watching.